Today we will be solving Fablong challenge. It's a live contest going on. So now the third problem is binary basics something, binary base something. So we will open problem statement here. You are given a binary string and an integer k. In one operation you can pick any bit and flip it. It is done 0. Can you make this thing palindrome using exactly k operation? Man, like strings and bitwise operators are very important. Like I have seen in many contests. Like I have attempted all of the starters till now in 2022, and I think in every contest they have asked a question around bitwise operators. So bitwise operators are very important. Okay, so binary basics. You are given a binary string s and an integer k. In one position we can pick and flip it. Okay, we can flip one bit at a time. Can you make a string using exactly k operations? We have to find out whether we can make a substring whether we can make a string as palindrome. Palindrome is basically a string which is saying whether we read it from left side or the right side, it is front or backward. Okay, if we can do so in exactly k operations, we have to print yes, else we have to print no. Test cases. The first line of each test case contains two space separate n and k. Second line give us the binary string. Okay, for output to print the answer yes, else no. Okay, 3 0 3 0 3 0. So the sample keys are like 3 0 where n is 3 and is 0, and we cannot flip one bit. Okay, and it is 6 6 and 1. Okay, so now let me try to explain this question to you. It's binary base basics. Okay, so now we are at third question and its title is binary base basics. So in the first case, like it is given a binary string. In this question we are given a binary string and of length L, something integer k. We will see what is this, and we have to do something with the palindrome. So first we will see what is palindrome. So what is palindrome? Okay, see, like my name is Jatin. If we read it from left to right, it becomes Jatin, and if we read it from right to left, it becomes a weird name, and it is Nitaj. Like it becomes Nitaj, and we can see that absolutely Jatin is not equals to Nitaj. Okay, so case 1. And another case is, let's say somebody name is somebody name is Navan. Let's assume that if we read it from left to right, it's Navan, and if we read it from right to left again, it's Navan. Okay. And see, these are exactly the same, and it is case 2. So in this case it is a palindrome. While it is not a palindrome. I hope now it makes sense what does the word palindrome means. Okay, so we just have to deal with this palindrome in case of binary string, and a binary string is basically just a mixture of 0 1 0 1 0 1 1 0 anything. Okay, so we have taken a binary string. When you read it from left to right, it becomes 0 1 0 1, and when we take a number from read it from right to left, it becomes 0 1 0 1 1 0 1 0, and it is 0 1 0 1 1 0 1 0. See, it is exactly the same. So it is a binary string. Again, if we take a binary representation of a number 2, like binary representation of decimal number 2, it's 0 1, and when we read it from right to left, it becomes 0 1. See, these are not equal, so it is not binary, it is not palindrome. When we look at a binary representation of decimal number 3, it's 1 1, and like whether we read it from left to right or right to left, these are both 1 1. These are both same. So it is a palindrome. I hope now you are clear about what does the word palindrome means in case of binary string or any string. Okay, like what does the word palindrome means. So now we have to just check. See now it is given at n equals to 3. N is the basically length of the binary string, and k is basically how many times we can flip. K is basically how many times we can flip bits of the given binary string so that we can make it a binary, so that we can make it a palindrome. Okay, palindrome. So in this case we are given a binary string of length 3, binary string with the length 3, and binary string is 110. See, if we reverse it, it becomes 0 1 1, and it is not a binary string. I mean, it is not a palindrome. It is not a palindrome. What if we were allowed to flip a bits? If we flip a bit one time, let's say if we flip a bit, let's say we will flip its first bit, so it becomes 0 1 0 0 1 0. And now if we reverse it, it will again become 0 1 0. Like if we go from left to right or right to left. Okay. So now we can see here we are getting palindrome. We are getting palindrome, but it is only possible when we are allowed to shift, allowed to reverse a bit. But in this case, k is 0. K is 0. It means we are allowed to flip bit maximum 0 times. It means k is 0 here. K is 0. It means without flipping bits, we cannot make it a palindrome. So its answer will be no. Answer will be no. We have to basically print out whether we can make the string as palindrome after doing some k operations at the bits, after flipping bits k times. If we can make it as a binary, we can make it a palindrome, then we have to answer yes, else no. Okay. So I hope the question is clear now. So now we will head over to its coding part. So now we will be starting our coding part. Okay, so first of all we need to take input for n and k. C in n k. Then we will take input for string, C in string. Okay, now we have to write a code for checking and for checking as well as for making the given string as palindrome. Okay, and now we will see how we will do it. Okay, first of all, writing our program code, that is binary based basics. Okay, so it is question third, binary base basics. Okay, we have to deal with palindrome. Okay, so consider we have a string, like we will consider two strings. First, which is already a palindrome, another one which is not a palindrome. Okay, see what we will do, it will be 1 0 0 1. Its index number is 0 1 2 3. It will check if 0 equals to 3, like if s of 0. Okay, it will check if s of 0 equals to s of 3. It means yes, it is palindrome, else it is not palindrome. It will check if s of 0 is equals to s of 3. Okay, it will go to next value. Then it will check if s of 1 equals to s of 2. Okay, they are okay, it fulfills the criteria for palindrome. It means it is a palindrome. Now it will come to this, it will be 1 0 1 1. Here it will check if s of 0, okay, if s of 0 is equals to s of 2. Okay, it will be 2 because it will be 3 3 because length is 4. Okay, so if it is equals to s of 3, it is yes. Then it will go to the next thing. It will check if s of 1 equals to s of 2. See, here it is 0, it is 1, so it is not equal. It is not equal. So it will say no, wait, it is not a palindrome. Now we will do, okay, don't worry, we have some advantage. We can make the string as palindrome by doing some manipulation, okay, by flipping the bit. So what we will do, instead we will flip this bit, so it will become 1. Earlier it was 0, we flipped it and it become 1, and it is 1. So now it becomes a palindrome, okay, because now after flipping, okay, after flipping s of 1, which is 1, it becomes equals to s of 2. It becomes equals to s of 2, which is already 1, okay. It means now it is a palindrome. So we have seen the case when it was already a palindrome, okay, and now we have seen the case when it was not a palindrome and we try to make it a palindrome by flipping the bit. And the number of times we flip our bit, we will store it in a variable called count, so that we can have a count of number of operations that we have performed, okay. So now we will head over to a coding part. First we will try to write code. See, for int of I equals to 0, I goes till n less than n, and I plus plus. It will check if s of I, see, if it is already if the bits at the position, let's say 0 and position n minus 1 are equal, then it means it is already satisfying the criteria, like the eligibility criteria for being a palindrome. So we do not need to perform any operation, okay. While if the bits are not equal, that is if s of I is not equals to n minus 1 minus I, and why we have taken n minus 1, because the index corresponding to last element is always n minus 1, okay. So if s of I is not equals to s minus 1, then we will make them equal, that is we will assign the bit present at s of n minus 1 minus I to s of I, okay. And we will increment our count variable. It means we are flipping the bit, okay. So and then we will increment our count variable, so we need to initialize a count variable, okay. So like what we are doing is here we saw in case of 1 0 1 1, we saw that s of 0 was equals to s of 3, okay. So like s of 3 is basically n minus 1, that is 4 minus 1 3 minus means 0, okay. And we saw that s of 1 here, it was not equals to s of 3 minus 1, okay. That is s of 1 was not equals to s of 2, okay. It is 0 1 2 and 3. See, it was not equal, we flipped the bit, that is what we did. We basically first we went to s of 2, and we assigned the same bit to the s of 1, that is we assigned same bit to s of 1. That is first we went to s of 2, we asked that brother, tell us what bit you have. He told that okay, I have 1. He told that I have 1. Then we copied its value and we went to s of 1, and we said that okay, now instead of your initial bit that was 0, we are giving you 1 value, okay. Now you have to tell that okay, I have 1. Now s of 1 will say that I have 1, and s of 2 is already having 1. It means the new binary string will be like 1 1 1 1, and now we can see that it is a palindrome, okay. And we have assigned, like we have flipped its bit, like we have stored, or we can say that we have flipped its bits 1 time, okay. Here we have flipped its bits 1 time, so our count becomes 1, ones, okay. Now consider a case when we have a binary string like 1 0 1 0 1 0, okay. Here n equals to 6, now to make it now first it would have gone to s of 0 0 1 2 3 4 and 5. First it would have gone to s of 0, it saw that s of 1 is not equals to s of 5, okay. So here count becomes 1. It means that we assigned value of s of 5 to s of 0 to make it as a palindrome, okay. And our count becomes 1 because we have performed 1 time operation. then it again went to s of 1, and he again saw that s of 1 is not equals to s of 4. Okay, so again count becomes 1, and then he saw that s of 2 is not equals to s of 3. So now again count becomes, okay, now 1 plus 1 becomes 2, and now count becomes 3. Okay, and after this operation the string becomes 0 0 1 0 1 0. Okay, because we assigned the value present at 5th to the position 0. Okay, now it was already 0. Okay, now we assigned s of 4 to s of 1, so now we assigned s of 4 to s of 1, so it becomes 1. Okay, now here it's like 1 0 0, and now we assign s of 3 to s of 0, so it becomes 0 0, and now see, it is our final string while it was initial string, initial, and here it is final. So we can see that after performing a total of 3 operations, we are getting our final bit, our final string as palindrome. Okay, palindrome. So in this code also we are basically trying to do the same thing. Whenever we are getting that s of I is not equals to s of n minus I, whenever we are getting that s of I is not equals to s of n minus 1 minus I, we are basically assigning the bit present at last value to the correspondingly first value. Okay, like we did at we assigned s of 5 to s of 0, s of 4 to s of 1. In the same way we are doing here, and we are just basically incrementing our count variable, that is we are storing the number of operations that we have performed. Okay, so when we will come out of this loop, our string would be a palindrome. Our string would be a palindrome. Now, but going to the question, we have to check if we can make the string a palindrome using exactly k operations. Okay, exactly k operations. If we can make it the palindrome exactly k operations. So now the thing is that the maximum that operations that we are allowed to perform is k. Okay, and here we are getting count. So we have to check if count is whether less than or equals to k. If count is whether less than or equal to k, it means that if count is less than or equals to k, we can have a sufficient, we will have a sufficient number of operations available to flip the bit. Okay, now consider one more case. Like we need to consider the case, because in this question we are asked if we can exactly k operations. We are asked to check if we can make it a string using exactly k operations. Okay, neither less nor more, exactly k operations. Okay, so now consider a case when we have n equals to 6 and our string is 0 1 0, and then it's 0 1 and 1. Okay, and k equals to 2. So see, here 0 is not equals to 1. Okay, it is not equals to 1. 1 equals to 1 and 0 equals to 0. It means after performing one operation, our string would be 1 1 0 0 1 1. It means that after one operation we are getting our string as palindrome. Okay, it means we still have one operation left. Okay, see, k was 2 and like we have performed one operation. It means k minus count, like calling it as count, k minus count equals to 1. We are bound to perform this operation because we have to perform exactly k operations. Okay, like we are bound to utilize this. Now consider a case if we flip further bit, like if we flip any bit one more time, then it's obvious that it will not be a palindrome. Okay, then it will not be a palindrome if we flip it bits one time. Okay, now consider if after flipping bit for the one time, again if we flip one time, then it will become palindrome. Okay, see, like for if after this we are again flipping bit, then consider a case that we are performing our third bit, so it will be 1 0 1 1. Okay, see, it is not a palindrome. Now again we are flipping the bit one more time, so it will be 1 1 0 0 1 1. It is a palindrome. Okay, it is a palindrome. It means that if k minus count is even, if it is even, then flipping the bit will nullify its effect. Okay, if it is a even, like we flipped its bit one time, so it became opposite of this, and if you flipped it bit one time again, then it nullified the effect of this changing flip bit. It means that if n, we have to consider whether k minus count is even or odd. Okay, we have to consider the k minus count is even or odd. It means we have to consider k minus count whether it is even or whether it is odd. Okay, so now we consider where cases if n is even or odd. If n is even or odd, see, in this case n was even, in this case it's even, so we have already seen the case when n is even. Okay, you can try to take n equals to 8 and then try to make a string on your own. You will land at the same solution, that if, like, it need to be even if n is even, if n is even. Okay, now consider the case when n is odd. N is odd, let's say the string is, let's say n equals to 5 and the string is 1 0 1 0 1. Okay, it's already a palindrome, it's already a palindrome. Okay, so the number of operations that we need to make it, that we need to perform, that is our count variable. So count variable will be 0, count variable will be 0. Okay, now consider a case that when it is 1 1 1 0 1, here it is not a palindrome, it is not a palindrome, so our count will be 1. Now consider a case when count equals to 2 3, like, consider, like, see, if count is less than equals to k, then we won't have any problem. Okay, so if consider a case, let's say if count equals to 2 3, it means that k must be at least equals to count. Okay, otherwise we won't have sufficient otherwise we won't have sufficient right to perform the bits. So if k equals to 2 3 4 5 6, any number, count is 1, it means that after one step, let me write it again clearly, when n equals to 5 and s is 1, it was uh, it was 1 1 triple. Okay, and it is 1 1 0 1. Here count equals to 1 for making it as palindrome. Okay, consider case when k equals to 2. So when k equals to 2, it means that k minus count equals to 1, k minus count equals to 1. So we are already having our string as 1 0 1 0 1 after performing this one time operation. Okay, after performing this one time operation, so see, it is a odd length, it is a odd length, means it will check for this thing, it will check for this thing, and it will, we can say that it will check for itself. Okay, we can say that it will check for itself. So when k minus count is 1, we will try to flip this bit, it will become 0. So the string will be like 1 0 0 1. See, we have not altered any other bits, we are just changing this bit. Okay, when k minus count is 1, it means now k minus count is 1, we have performed one other operation, so now k minus count becomes 0. It means that we have already utilized all the maximum operations available. Now consider when k equals to 3, k equals to 3. Okay, so k equals to 3. Now after performing this operation, we can still perform one operation. Okay, so we will make it as 1 0 1 0 1. That is, again we have flipped this bit, again it is a palindrome. Now consider when k equals to 4, after performing this operation, again we will have one operation left, so again we will do it as 1 0 0 1. Again it is a palindrome. So what we are seeing is that if n is odd, what we are getting is, if n is odd And if count is less than equals to k, then we need not to worry about nature of k minus count, whether it is even or odd. Okay, no tension, we need not to worry about it. So so now we can conclude. So now we are trying to conclude that if count is less than equals to k, okay, then we will make cases. N is even if n is even, then we need to check if k minus count is even. If k minus count is even, if it is so, then it will see out yes. Okay, else if count is still less than equals to n, less than equals to k, if n equals to odd, if n equals to odd, then it will see out yes. Else it will see out no. Okay, so now if count is less than equals to k, we have already verified, like we have already restricted condition for count. So now we will check if n is even. Okay, if n is even and if k minus count is also even. Okay, if k minus count is also even, here it is for this thing and it will be for this thing. If it's so, then it will see out yes. Okay, else if n is odd, then also it will see out yes. Else in other cases it will see out no. Okay, I hope it will not give any compile time error. Okay, so now I have just pasted its like sample cases which are given in the question. Now we will try to run it. Oh man, compilation error, n was not okay, no match operator. Okay, my issue, I mean my error. It's running now. It's showing yes. If count is less than equals to n, okay, we have to write the case for if what if count is not, like what if count becomes greater than k. Okay, so now it's giving no yes, and it's exactly the same as our sample output. So now we will try to submit this code. Yeah, bravo, our answer got correct. Okay, so I hope now you are able to understand what this question is and it's like what we have done in this question. So now trying to summarize what we have learned in this question is, first thing that we have learned is what is palindrome. Okay, I hope if you have understood this concept, you will not get confused next time. What is palindrome? How we can check if it is palindrome. Okay, how can we make how can we make a string as palindrome? Last but not least, Feblong 2022 Codechef. Question third. Binary basic problem. Well, the important concept that we have understood in this question was what is palindrome, how can we check palindrome, and how can we make palindrome. Okay, well, at last I would like to request you, if you have found this video useful, if you have learned anything new, okay, if you have even got your error, like what error you are doing in the contest, then do like, share, subscribe the channel, and do please show some support. Okay, by mentioning in your comment if you have found this video as useful. Thank you very much.